So this is lesson 6, and today we're looking at acceleration near the Earth's surface. And just so you remember, yesterday we were talking about from lesson 5, there are a couple of equations that we can use when we're doing acceleration. So one very important thing is that the first equation we've learned is the constant velocity equation. V, velocity, is displacement over time. And keep in mind that every time if the question mentions something like, oh, the car was traveling at a constant velocity or something like that, this is the only equation that you're allowed to use. Okay? But anything else, they tell you, oh, the car was traveling and it stopped, or like, oh, a person was at rest and started accelerating. All these things that are involving acceleration, you're going to remember that you're only allowed to use the high fives, which you should have memorized and have done an awesome job knowing your equations. Okay, and every time we're dealing with high five, you would notice that every single of those high five would have 4 variables. And from the question, you should be, in general, looking for 3 givens that are given in the question, and there's always this one thing that we are looking for, which is called the unknown. And then what happened is, because with the 3 givens and 1 unknown, we're going to look for the specific equation from the high five that would be giving me only these 4 but nothing else. Okay, so we're going to spend more time reviewing that today. Okay, so talking about gravity, we are there's a couple of things that we will be focusing on. Okay, so first of all, we all know that gravity is like the force that is causing all the objects to accelerate towards the Earth's surface. Okay, and we are, every time when we're using the word acceleration due to gravity, another big word that we would use would be free falling. Okay, it could be anything like a pen that is being dropped from my hand onto the ground, or like somebody is throwing something upwards and then eventually it's falling. Those are all going to be considered into free falling. Okay, and when things are free falling, we're kind of having this assumption. Yes, in physics we do a lot of assumptions. Whenever we're dealing with free falling, we're always assuming that it doesn't have any air resistance. We're always assuming that there is an absence in air resistance, because in real life, if there is actually air resistance, your acceleration is not always going to be the same. Okay? So anytime that when you see the lesson, when you see anything that has a video clip, what I need you to do is I need you to go on Moodle. I need you to kind of maybe pause this video and go to Moodle and click on the video to watch what I'm trying to demonstrate to you. Okay, so going further. So one extra value is this. Okay, so yesterday we say, oh, there is something that is accelerating. And every time when they are telling you something that is accelerating near the Earth's surface, very important that is near the Earth's surface, because the value would be slightly different when you're actually very far from it. Say something on, like, say, the International Space Stations or something like that, it is not 9.8 anymore. But when it's near Earth's surface, and when we're talking about smaller objects like a car traveling or anything that is very close to the Earth's surface, we are assuming that it has acceleration due to 9.8 meters per second down. Okay, it could vary slightly, okay, depending on the altitude. Okay, so the next kind of concept is like, what if there is air resistance that we are going to be considering? So the first term that you need to kind of remember, first definition that you need to know, is what is terminal velocity. A very good test question on a typical, kind of like a typical test question. So a term is like, oh, please explain what is the terminal velocity. Okay, so I need you to imagine, okay, if I have a piece of paper here, and if I also have a piece of paper but I crumble it up, notice the mass is exactly the same. But when I actually drop it to the ground, who do you think will hit the ground faster, right? You're going to tell me that, oh, the piece of paper that is crumbled up is going to go very quickly, but then while the piece of paper is going to be drifting quite a bit slower before it gets to the ground. And the reason for that is not because the force of gravity is smaller. Okay, if you actually take a look at the paper as well as the crumble up or the free fall, they both have the exact same magnitude of the force of gravity. Okay, so I'm using the exact same arrow of Fg that's going downward. But what happened is, because of the surface area, what happened is they have a air resistance that's going upwards. What you would notice is that the air resistance, we use a F air to represent it. The F air for the big piece of paper versus the grubble piece of paper was going to be much greater. And for that reason, you're actually going to cause an overall net force to be different. And so, air resistance actually can have a significant effect on the motion of a falling object. And when the air resistance is equal to the force of gravity, we use this word called the terminal velocity. It is terminal for the fact that, you know what, it is actually not accelerating anymore. It is actually going to be traveling at a constant velocity. It will still be falling. Remember, right? If you're at a constant velocity, you could still be moving, but you're just not speeding up anymore and you're not accelerating anymore. So please remember the term terminal velocity. Okay, it means that air resistance is going to equal to force of gravity causing a constant velocity. This constant velocity is going to be called the terminal velocity. Okay, so one definition that you need to know for this lesson. Okay, so moving forward now, we're going to be solving the high five questions, but this time definitely need to recognize if we're talking about acceleration due to gravity. So just like all good problem solving that we would do is we would always kind of look at the question. I always like to highlight things just to make sure that I have all the stuff I need. Okay, so it tells you examples. A flower pot is knocked off the window latch. Okay, when you see knock off, you know right away that, oh, hey, I know this is free falling. Okay, so I'm dealing with something that is free falling. Okay, right away I know that they have given me the variable of 9.8 meters per second square down for the acceleration. Okay, then it tells me that it is accelerating uniformly to the ground. If the window ledge is 10 meters above the ground and there is no air resistance, how long does it take for the flower pot to hit the ground? Okay, so a couple of things that this is meters. Hopefully we're able to recognize that, hey, that is displacement. Okay, displacement is 10.0 meters and it's going from the top to the bottom. When it's going top to bottom, beginning to the end, it is downwards. And it's asking you how long will it take, so that is my delta t. And last thing is, I feel like I'm missing a variable because didn't we say that we will need 3 given and 1 unknown? I seem to only have 2. I still need 1 extra piece of information. Okay, and that piece of information kind of come from the wording and a little bit of common sense and a bit of you've done enough practice that you know that, you know what, when a flower pot is knocked off the window ledge, we do need to assume that the initial velocity is 0. Okay, so look at this. I got 3 given, A, delta D, and V1, and 1 unknown, T. Now you have to go back to your high fives and look for the equation that has these 4 variables, only these 4 variables, but nothing else. So hopefully at this point you recognize that the equation is this one. Okay, so what I do need you to remember is that, okay, you have to put your arrows above all the vector signs and don't forget the square, don't forget the t's and stuff like that. So A, D, T, and V1 are the only variables that are here. Okay, now I'm going to start plugging in my numbers. Okay, hopefully you're appreciating that V1 is 0. When V1 is 0, anything times 0 is gone, so this whole term is gone. So I'm left with delta D equals to 1/2 AT squared. So delta D is 10 equals to 1/2 A was the 9.8 that we got times delta T squared. Rearrange the equation. I'm going to show you the full steps. Okay, but remember, anything that I write in blue are not things that you have to do. Okay, so I got a 1/2 here. If I want to bring the 1/2 over, I have to multiply by 2. So I have 2 times 10 equals 9.8 delta T squared. To get rid of the 9.8, I'm going to have to divide both sides by 9.8. This is now gone. So 2 times 10 divided by 9.8. I have something that worked out to be 2.04 equals to delta T squared. To find the T, I'm going to have to take a root on both sides. So my final answer would work out to be something like a 1.4. Don't forget to check your question, how many sigdigs there are. There isn't anything here. There's 3 sigdigs in this question, in this variable, and 9.8 has 2 sigdigs. So the answer should be expressed in 2 sigdigs. Don't forget your unit, and that is your full answers. Okay, so finishing off, this is almost like a part B of the question. They are asking you to find, hey, what is your final velocity just before it hits the ground? First of all, very easy misconception. Somebody's going to tell me, oh, it's going to be 0. Okay, it is not 0. It will be 0 after it strikes the ground and got slowed down, but right when it hits the ground, it is going to hurt, so that it is not just 0. Okay, so if you go back to the given that we had, you still have your A, you still have your V1, and you still have your D. And now they want you to find out what is your V2. Okay, so now, I guess the only new thing that you've learned today is knowing that A is 9.8. Don't forget your direction, because I'm looking for V2, which is a vector quantity. Don't forget your direction to be included in that. Okay, so 9.8, so I have A, V1, delta D, and V2. So the equation that contains these 4 variables but nothing else would be your V2 square equation. Remember, every time when you're watching these videos at home, right, don't feel like you have to just keep watching everything, right? A very, very good practice you could do is actually pause the video, try out the question before you actually look at how I solved it, because that's how I would have done it in class, right? So please maybe try to do that, like pause it before you actually look at the solution. But I've forgotten to remind you, but that's okay. All right, so let's keep going. So V2 squared equals to V1 squared, which is 0, plus 2A delta D. So I'm just going to do it all in one step. So I would be going like, oh, 2 times 9.8 times 10 equals, and then take the square root of that. So the answer that I have gotten is 14 meters per second, keeping 2 significant digits because of the 9.8. And of course, we're not going to forget the direction, which is down. So this is your 3 full mark equation. Show your work and answers with the correct sigdig. Don't forget, you would lose half a mark because of sigdig. You might also lose half a mark if you're missing unit. And of course, don't forget, another communication mark is the direction. These are vector questions, and I do expect you to put directions as well. Okay? All right, question number 3. Okay, so pause the video if you feel like you could be working on this by yourself, and then play it again. But I'm just going to keep going. So a tennis ball is thrown straight up in the air, leaving the person's hand with an initial velocity of 3 meters per second. How high from where it was thrown does the ball go? Okay, so let's write everything that we know. Okay, it tossed upwards, so is it okay if I assume that we are free falling again, right? The object left the hand and is now just have the effect of gravity, so I can confidently say that, hey, I know my acceleration is 9.8 meters per second squared, and it is going downwards. Okay, it tells you it leaves the person's hand with an initial velocity, which is V1, equals to 3 meters per second going upwards. Okay, so hopefully alarm blah 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 is already ringing that I have an up and I have a down, and we don't like that. We can't use the different direction on the same with the same equation, so we're gonna have to actually change it, right? So it's up to you. You can change this to an up or change this to a down, whatever your preference is, as long as you're keeping consistent. So why don't we change V1 to a down? We're going to assume down would be the positive direction in this question. So I'm going to put a negative in front of the 3 so that now it is down. So what we've done right now is we are assuming that down is the positive direction. Okay, so anything, if we end up with a positive answer, great, it is down. But if we end up with a negative answer, that means we're actually going upwards, okay? So finally, it's asking me how high, so which is delta D. Uh-oh, missing a variable. What do we have? How high will it be thrown? Does the ball go? Okay, It is telling you that you have a ball that is here and it's going upward, and they're asking you, hey, how high would this be? Okay, what extra thing do I know? Okay, so we only like have 5 variables to play with. Okay, we got a, v1, and delta d already. So the other 2 things that we can possibly have would be these guys. Okay, I don't really know. Okay, by looking at this question, does it give me anything about time? Does it give me anything about v2? Okay, hopefully you're picking this out, but we actually have v2 equals to 0. That's a really picky part. This is the part that people often miss. So I'm going to put a star in front of it, maybe another one, and another one, and another one. Every time when they're asking how high, it's almost like hiddenly they're telling you, hey, this is going at maximum height. If you imagine a pen or a ball leaving my hand, it was going really fast, it would have to slow down by gravity before a stop, before it will come back down again, right? Do you know what I'm saying? Right at the top, it's gonna have to stop before it can come back down again. So the highest point always have a final velocity of 0, and that's gonna be another extra piece of variable that we're gonna have to use. All right, now it becomes just a regular kinematics question. We find the equation. Okay, so A, V1, delta D, and V2. You're very welcome to refer to your equation sheets, but eventually with enough practice, hopefully just looking at this, that you get good enough that you'll be like, hey, I know exactly what equation I'm using. So hopefully that day will come very quickly for you. Okay, so this will be the equation that I'm using. And I'm going to start plugging things in. So V2 is 0. Equals to v1, which is -3. Do not forget to put them in the bracket because the whole v1 is -3. So I'm gonna have to square the negative as well, plus 2 times a times delta d. Okay, be very careful of your signs because right now, when I'm doing the question, I have 0 equals to a +9. -3 times -3, that makes it positive. Plus, if I go 2 times 9.8, this is 19.6 delta D. All I did is just expand out the equation. I wrote this in blue. As I say before, you don't have to write them out. Okay, these are just the steps. So, that math's backwards bad math. I'm going to have to bring my 9 over to the left-hand side by minusing. Okay, solving for delta D, the next thing that I'm going to have to do is I'm going to have to divide both sides by your 19.6. So punch it in your calculator, -9 divided by 19.6. So I got something like a -0.46. Negative, negative. What does a negative mean? Hopefully you remember, negative is just a direction. It really just means that the object has traveled 0.46 meters to the outwards direction. But leaving it as a -4.6, it is -0.46 is totally fine. Okay. All right, so this is now done. So don't forget, like, you have to try these questions on your own. It will not make sense to you. I know it looks really easy when I do it up here, but there's so many different scenarios, a lot of things you need to practice on. So please make sure you try out your practice question.